So we move the -3 over to the other side, and when we move something to the other side, it changes signs. So this time it becomes a +3 is equal to y squared. Now we're looking for y, not y squared. So what we need to do is take the square root on both sides. And so we therefore get y is equal to, now you have to be very careful with this. I'm not sure if Mr. Marks has mentioned it to you, but when you take the square root of a number, you get plus or minus, and then we get the square root of 3. So for this one, we have two y-intercepts, the positive square root of 3 and then the negative square root of 3. Now there are certain instances where we don't include the plus or minus, and those are instances when we know for a fact that something is not negative. For example, distance. Whenever you were working with the distance formula, it does have the square root, but we don't use it. We don't use the plus or minus because we know that a distance can never be negative. It's always positive. The alternate form of this is going to be, again, what do we know is true at x? That it is equal to 0. So we have 0 comma square root of 3, and we have 0 comma negative square root of 3. Okay, and that's also an acceptable solution. Okay, so as you can see, that's what the slide says our answers are. Okay, moving on. This time another type of example says to find the x and y intercepts of y is equal to x cubed minus 4x. Okay, for this one it's going to be a little bit more complicated, but again it's basic algebra that you should remember how to do. So let's see. We're going to find the x-intercepts first, and what do we know is true at the x-intercept? I always like to jot that down. We know that y is equal to 0 at the x-intercept. Alright, so here we go. We're going to start off with our equation first. Y is equal to x cubed minus 4x. Now we're going to go ahead and apply what we just stated. The fact that we know for sure is that y is equal to 0. So we get 0 is equal to x cubed minus 4x. Now this problem has just turned into Algebra 2 section, spring semester, whenever you, not spring semester, fall semester, whenever you were learning higher order degree polynomials, whenever you were learning synthetic and long division. And a lot of the questions were asking you to find the roots or to find the solutions. Okay, well in this case, it's already equal to 0. So the next step would be to factor out what they have in common. Higher order, usually that would be the next step. Factor out what they have in common. In this case, they have an x in common, and then you can only factor one out. That would leave you with x squared minus 4. Okay, then after that, you would set each one of these equal to 0 and solve for x, like in Algebra 2. This one is easy because we already have it. So our first answer is going to be x is equal to 0. Or 0, comma, and what do we know y is? 0. So that's our first x-intercept. Then we have x squared minus 4. and we're going to set that equal to 0. So we have x squared minus 4 is equal to 0. Move this negative 4 to the other side, and you get x squared is equal to positive 4. However, you don't want x squared, you want x, so you're going to have to root both sides. And you get x is equal to, this is a nice number, but remember you get plus or minus, and the square root of 4 is 2. Or plus or minus 2, comma, 0. Now, what I want you to notice is that you get how many x-intercepts? Count with me. We get the positive 2, we get the negative 2, and we get the 0. That's 3 x-intercepts. What is the highest exponent on the letter x in this equation? As you can see, it's 3. That right there, the highest exponent on the variable you're trying to find the intercept for, that tells you how many answers you are going to get. So this 3 here tells us we're going to need 3 x-intercepts. Alright, so now that we've done the x-intercepts, now we need to do the y-intercepts. So what do we know is true at the y-intercepts? And that is that x is equal to 0. Alright, and so we go ahead and write our equation. As I said, I always like to write down my equation. Y equals x cubed minus 4 times x. And when you plug in 0 in for x, you get 0 cubed minus 4 times 0, which gives you 0 cubed is 0, minus 4 times 0 is 0, and 0 minus 0 is 0. So your answer for this one is that x is already 0 to begin with, comma, and whatever you got for y, which in this case is 0. And that's our answer. Notice again the highest exponent for the y, because you're looking for the y-intercept, is 1. That means that you're only going to have one y-intercept, and in this case we do. We only have one y-intercept. Okay, moving on now to symmetry. There are a lot of functions that you will be seeing in the future that will have symmetry. For example, we have this parabolic function, which has symmetry about the y-axis. The next picture or graph that's shown has symmetry about the x-axis, and the next one has symmetry about the origin. Okay, so you're going to have to remember that. So, let's just take points in the first quadrant, and we know that everything in the first quadrant is positive. So, if it has symmetry about the y-axis, there's going to be a symmetrical point on this part, but you have to remember your signs in the second quadrant. The x would be negative, and the y would still stay the same. So it would be negative x comma y. We're going to apply that same logic to something that has symmetry about the x-axis. Remember, everything in the first quadrant, as it is here, is positive, but it's going to be symmetrical to some point on the other side, which we know for a fact will be a positive. First you go this direction, so it'll be a positive x, and then you go down, so it would be a negative y. And then finally we have something that has symmetry about the origin, and again we start in the first quadrant, which we know for a fact is xy, and it's going to be symmetrical somewhere on this point here, which if we follow the signage, it's going to be, if we go this direction, it'll be negative, and then this direction, it'll be negative as well. So we'll have negative x, negative y. You must remember those properties. As I've mentioned to my students, they are kind of common sense things that you really don't need to stress about remembering. If you think about it and think it out, it comes naturally. It's a common sense type of problem. Okay, this one says check for symmetry with respect to both axes and the origin. So we have to check for symmetry with respect to the x, to the y, and the origin. Okay, so let me go ahead and write that one down. Xy cubed plus 10 is equal to 0. Alright, we're going to start with something that's on the y-axis. That's the first sketch that you saw in the picture. And what do we know for sure? That it goes from x comma y. In case you didn't get it, let's relook at that picture. It goes from x comma y to negative x comma y. Negative x comma y. Alright, so let's see. Okay, so our equation is x y cubed plus 10 is equal to 0. And let's look at the transform one, the symmetrical part. We plug in a negative x every time we see an x. So here we go. I'm going to plug in a negative x. Y cubed plus 10 is equal to 0. Okay? And a negative times a positive, so that's going to give us a negative x y cubed plus 10 is equal to 0. And then what you're going to do is you're going to take your final equation and compare it to your original. Is it the same equation? If you come out with the same thing, then it is symmetrical. If you don't come out with the same thing, then it's not symmetrical. So as you can see, it's not the same thing, so this one is not symmetrical about the y-axis. Okay? Now we're going to move on. So that's the one that we just did right there. Then I'm going to say, well, let's plug in for the x-axis. And if you recall the picture, it goes from positive x comma y to positive x negative y. So let's see that when we plug it in, we'll get the same thing. So here we go. We've plugged it in, a negative y cubed plus 10. Whenever you cube something that's negative, you're still going to get a negative y cubed. So we end up getting negative